So thank you everybody who's here tonight and managed to get here. So my name is Petra and I'm a member of the AABR Walks and Talks group, and we have a fantastic presentation by Shirley McLaran today. And we acknowledgement of country. AABR acknowledges the traditional Aboriginal Torres Strait Island custodians throughout Australia and their continuing connection to land, waters and community. We pay our respect to the elders, past and present and future, for they hold the memories, traditions, culture and hopes of Indigenous people across the nation. And if you would like to join AABR, please use your phone for the QR code. And AABR, for those who don't know about AABR is a non-government organization that works across all sectors involved in influencing bushland management. We aim to encourage best practice, improved resourcing, and greater community engagement. And there is a poll now on your screen. If you can please answer the question, who's in the room? Choose the option that best represents your connection with bush regeneration. And I think at the moment, most people seem to be coming from on-ground volunteer. Couple of contractors and a couple of government employees. And I'm part of the Walks and Talks working group for AABR. So, and if anybody else out there has any ideas, like interest you would like to share, please let us know. We are open to all of suggestions, or come along to one of our meetings. We are very open, easy, it's online. So anybody who has a bit of time, and you can be involved as much as you want or as little as you want.
Yep. Yep.
Okay, I think that was the poll of who's watching the webinar. So as before, I think we are still most on-ground volunteers. Next group is on-ground contractors, couple of local government employees and a business owner or consultant. So thank you all for coming along today. And this webinar, it's not quite a webinar, it's a meeting. So please ask questions via the chat. So there isn't like a Q&A function here. Use the chat to share your information with each other or make comments. And please mute your microphone. And the agenda for this evening is like a bit of introduction, which we just now did. Then Shirley will give a around 40-minute talk. Then we have 10 minutes question and answers at the end. And then hopefully should finish at 7 p.m. So you can all still go and watch the State of Origin for anybody who's interested. So, and now we like introducing Shirley. We're very grateful for Shirley to have Shirley with us today, sharing extensive knowledge of pea flowers. I first met Shirley really online through iNaturalist. So she's one of the sort of go-to persons for pea flowers on iNaturalist, and we sort of had quite a few online discussions about weird topics about our native Dilvinias, about how long the peduncles are, or if flowers are terminal or not, or have pointy leaves. So if you use iNaturalist, I highly recommend like sort of getting in touch with Shirley if you've got any questions there. And Shirley is also the leader of the Australian Plant Society's pea flower group study group. So if any of you are part of the APS, I would also highly recommend joining her group. There you learn quite a bit. So please join me in welcoming Shirley, presenting Don't Be Afraid. So thank you, Shirley.
Okay, thank you. I'll share my screen. This will stop sharing. Yep, that's okay. I'm going to take over and share. And from the beginning. Why is it not starting? There we go. Now we're starting. And just following on from what...
Sorry, Shirley, I'm not seeing your screen.
Oh, okay.
Is everybody else?
Yeah.
Is
Can
that
anyone see it?
I can see it.
You can see it. Oh, sorry. Okay. Yep. Oh, sorry. Yep. Different button. Yep. Great.
Yes,
Sorry.
I
Thank
think
you.
we've got
Yep.
two buttons.
I had no idea what to.
Okay. Lots of
Yeah.
thumbs. Everyone can see it. Wonderful.
As I'm sharing. So far, thanks, Petra, for the intro. And since you mentioned iNaturalist, I'm Sweet P28. So hopefully it's easy to remember. And yeah, I spend a lot of time on there, both observations and IDing, and I recognise a few names that I've seen coming in, I think, that I might have seen on iNaturalist. So I'll get started. Actually, this year's the 30-year anniversary of me joining the Australian Plant Society. But my interest came in peas, mainly just by going to excursions and, like your walks and talks, conferences, and became fascinated with peas when I realised there were so many different genera. So Australia's got about 140 genera of native peas. And I was amazed that people could just, go, that's a Pultonia, that's Gomphalabium. And I just thought, how do you do that? And that's became my obsession ever since. So in 2019, I resurrected the study group for pea flowers. There'd been a couple of other times that it had been started. But it is a big group. It's not like, all the eucalypts, which, in numbers probably similar, but it's one genus, or acacia's one genus. This is a lot of different genera with similar flowers. So, but I'm pleased that I started that in 2019, and we've got about 180 members now, with different focuses, identifications, my main interest, but I also grow peas, local peas. I'm in the Hunter Valley, and I also now volunteer at Trees in Newcastle, and that's how I first got involved with that, was going to see what peas they had to say. So it's all connected, and just the title of the talks, Don't Be Afraid, because I recognise that a lot of people are afraid of identifying pea flowers, and also to some extent growing them is not easy. I won't be covering that today. I'll just be focusing on identification. And to get started, I polled the study group members back in 2024 when I first did this for a national conference, did this talk. And my favourite reply was, "Oh no, it's a yellow one." And that just about sums up, what everybody thinks. Yellow and red. There's a lot of them. They all look the same. So hopefully tonight I can give you a few pointers to recognising some of the genera with some tips. So I'll just have a bit of a look at this word cloud that came out of that survey. And word cloud, obviously the bigger and the bolder as the more times it was mentioned. So pleasing to see people recognise they were Fabaceae. Also nitrogen fixing, we'll talk a bit about that. Eggs, and they're often called, well, the yellow ones with red markings are often referred to as egg and bacon plants. And there's yellow, colourful. So there's a lot of things people think about with peas, and also the words highlighted in red are plant related, either scientific names or common names. So interesting that a lot of people know the genus name, Pultonia, Dilwinia, Eutaxia, and refer to them as such. So a little quick bit about the classification, mainly because there has been some changes over the years, and the reason I called this the Australian, the study groups, the Australian pea flowers, is to separate it from the acacias and the sennas. So it's just looking at those legumes. So the Fabaceae family is the legume family, and that's their because they're a pod, a legume. That's the fruit formed from one carpel and has two longitudinal lines of dehiscence. So they open on two sides. That's the botanical definition of a legume, but there's a lot of evolution and variation on that. So Fabaceae was once the family name for just the pea flowers, but now we recognise Fabaceae as the family that incorporates pea flowers, acacias and sannas. So the pea flowers is the subfamily Faboideae, and that's what we're looking at. It's got that unique pea flower, but it still has legumes like the other subfamilies. The tribes I've mentioned there is a lower ranking than subfamily, but higher than genus. And that's the reason I'll probably mention Faboideae and Faboideae tribes. And the reason for that is they're the two biggest tribes, and 60% of our native pea flowers are in those tribes. So all up, there's about 1,700 species of peas in Australia, and 1,100 of those are native. And about 60% of Australia's endemic Faboideae are the egg and bacon peas, and they're in those two tribes, Faboideae and Faboideae. Mostly Faboideae, but a few Faboideae as well. So that's why I'd like to mention those. Faboideae alone, about 750 species. And when you consider a lot of those are yellow with red markings, that's where it can get interesting. So some of these things I've already mentioned, but this is a pea profile. Family Fabaceae, and you may also see in old texts or old reference books Papilionaceae and Leguminosae, which I can never say, but they previous names for the Fabaceae family. The subfamily Faboideae. The largest genera in Australia are Fabaceae, Pulcinea, and Gastrolobium, and they're all over 100 species in those genera, and they're all in the Faboideae tribe. The plants come in all forms: trees, vines, shrubs, and herbs, found in every state and territory, and just every possible habitat, coastal cliffs to the alpine areas. And ecologically, they're very important. They're attracting pollinators. They're known for their nitrogen fixing. All the legume family, that's one of the characters, is that they can, with the symbiotic relationship with soil bacteria known as rhizobium species, they're able to fix nitrogen from the atmosphere in the form of ammonia and make it available to plants. Otherwise that nitrogen wouldn't be available. So by doing that, it's improving the health of soil. They're also long-lived seeds with a hard seed coat, so they're components of the soil seed banks, important for bush regenerators, and they've got long viability. They'll recolonise disturbed areas. That's particularly a lot in Western Australia. If anyone's been over there, you'll often see them in disturbed areas, and also regenerating after fire. And one of the reasons for that is the fruit, the pods, the seeds have a little fleshy appendage called an aril, and they're very attractive to ants. It's a little protein ball, so they take them back to the nest. And often, after fire, all those seeds will germinate. So the yellow. The peas are hard to see when they're not in flower, but you certainly can't miss them when they are in flower. And you'll often get, just one species en masse in an understory. So a couple of years ago, I was at Yango National Park, and this Podylobium alyssifolium. And I noticed as we were driving through the dirt roads, the plant that was en masse, it actually changed. It was like, there was a block of Podylobium illicifolium, and then you go on a bit further and it was Fabaceae ilicifolia, and that would change. So yeah, that's when I found out it's because the ants taking those seeds back to the nests. So just a quick look at this is how I think of peas, my collage, weighted heavily towards the yellow and red ones. I'm not going to go through all of those, but we'll see some as we go through them, and also down the bottom there's you know, all the other colours as well. Some genera like your Hardenbergias, Hovia, they're all, you know, often, you know, people know them as purple. There aren't as many, and they're more easily remembered, whereas the yellow and red colorations, there's a lot more of those. So that's what we're going to mainly focus on tonight, is the bacon eggs, egg and bacon. But firstly, I'll just have so I don't know who knows the pea flower, but we'll have a quick look anyway, just to start it off, how you recognise the pea flower. So, as I said before, it's a very unique, you know, structure with these petals and the arrangement of the petals. It's a pea flower. It's in subfamily Faboideae. So it's got the large petal called the standard, the two lateral petals, the wings. So this Gomphylobium latifolium is a good one to show you the separate, like the different colours. So it's a good one to see. The yellow is the wings and the green is the keel. So there's actually two petals fused together to form the keel and named for its boat-shaped structure, and that encloses the stamens and carpel. And on this one, you can see the hairy margin. That's a diagnostic feature of, in the eastern states. I'm not as familiar with the peas in the western states, so a lot of my photos will be from the eastern states. In the eastern states, Gomphylobium latifolium and Gomphylobium hugeli both have this hairy keel. So I mean, that already, you know, narrows down a lot when you're trying to identify the plants. And from the side view as well, this is the standard here. I hope you can see my cursor because I'm drawing with it. And then you've got the wings and the keel inside. You can see that hairy edge once again on the edge of the keel. So it's had something in my head then, and it's disappeared. So that's that's a very typical, if you can say, typical pea flower, but there is a lot of modifications. It's evolved differently in different parts. So we'll see some examples of that. So that, you know, they're not all going to look exactly like that, but that's a very good example. Okay, so I like to see, well, I think of identification as a process of elimination, especially, for example, you know, bush regenerators, you might just have a small area that you do, and really if you just look at what's in your area, you've already eliminated, you know, a heap of plants that it can't be. So, and another way to start off, if you're not familiar with a pea flower, is to look at the symmetry. So pea flowers have what we call irregular or bilateral symmetry. They're like ourselves. They can only be divided into left and right halves through one plane. So they're just like mirror images in one way, compared with a plant with radial symmetry that has parts that are around the center that are fairly regular parts, and they're spaced around the center. So you can see from the dotted lines that can be divided in several ways, more than one plane of symmetry. And also on the next page, just to what I notice is a lot of people, and it is easy to see why, the similarities between the Faboideae and Petioideae, both yellow, both have legumes, both in the Fabaceae family. But you can see the Petioideae has these 5 distinct petals that you can see, whereas the pea flower, the 2 joined together, the keel, are quite concealed. And that houses the reproductive parts, whereas they're on full display here. So it's just one to remember. Petioideae isn't a pea flower. The others are, there's probably not as many in that group as there are the peas. So standards. I've put 8. Well, they're sort of from all over. I included a couple of the gastrolobiums, pretty much since a recent revision. Gastrolobiums are in the western states and Pultonea in the eastern states. East rarely meets west with the geographical biogeographical divide. There's it's really evident with the pea flowers. There's a lot of species in the west that we don't see over here, and Pultoneas were recently revised, and they're pretty much all in the eastern states, including Tassie and South Australia. There's one only now that extends into Western Australia, and also Gastrolobium. They're Western Australia, except for 2 that extend into Central Australia. It makes it a lot easier. Well, not so much. It's still difficult, but you have got that distinction. But these, the 8 of these I've picked here are fairly, more widely known, I guess, genera. And the purpose of it was to hopefully you can start to see that when they're side by side, some differences. And I think the easiest one to recognise is a Dilwinia. So put it up front first. The standard is wider than it is tall, so it's got what is sometimes referred to as Mickey Mouse ears, and it's quite distinctive. But I will say that there's not one model for every genus, unfortunately. They do look similar, and within a genus they can be different. So there's some Dilwinias that have a higher standard and aren't this typical kidney-shaped. But if you see one like that, it's pretty much going to be a Dilwinia. Phylota and Aotis are very similar, although you may be able to see that the Phylota standard is quite narrow, so it's probably narrower than it is tall, whereas Aotis is quite blocky, similar, equidimensional. But they both have very deep keels, so the keels are incurved, and that's why they look deep. So that's the first thing. You could narrow it down to maybe a Phylota or an Aotis based on that keel. And I'm going to look at them in more detail in a few slides' time and point out a few other ways to differentiate between them. Pultonea and Gomphallobium, though those 2 photos that I've picked look very similar in size, but one's got the red markings, the Gomphallobium doesn't. It's not to say they're all yellow. I think there might be 1 or 2 that does have red markings, but there's also a lot of other just solid colours in Gomphallobium. It's got an amazing range of colours. And even the Pultonea, there's a pink Pultonea grows in the Grampians, which is still have yet to see. Also, Divisia, Gastrolobium, and Eutaxia. To me, they look similar in shape and size, like a more compact flower, but they can be differentiated on other things. So the message here is just the flower may not be enough to differentiate them. And let's face it, most of the year you don't have flowers anyway. So learning to identify through other features such as the foliage and what to look for, and also the fruit, and then using things in combination is how you're going to be able to I start identifying and distinguishing the genera from each other. So Devesia, the foliage is actually not a true leaf. It's a phyllodes, which is modified for our arid climate, and it's a flattened petiole. So the petiole's the stalk of a leaf, so it's actually a flattened petiole. So there isn't a leaf or a lamina. In Devesia, gastrolobiums, they're either I think the main point of difference there is their location. They're Western Australia. And before, when the Pultoneers were also in Western Australia, the main difference was the stipules, which we'll talk about. Pultonea has fused stipules, gastrolobium, they're not fused. So there's little differences like that that help you identify pea flowers. Eutaxia, the main point of difference there is the foliage. The leaves are opposite and decussate. So what that means is each pair of leaves is at right angles to the pair below and above them. So when you look down a branch, it looks like an X because you've got that crisscrossing pairs of leaves. So another way that you can pick and these rules, they're not, nothing's hard and fast in the plant world. They're 99% of the time, I know what I'm saying, but there's always going to be the odd a difference here and there. So let's go over to the next one. So I've started with the standards or the petals. That's the main thing you'll look at in a flower. But I'm going to work down to the rest of the structure behind a flower, because you can see a whole lot more by looking at these other structures. And so behind the petals, you've got the calyx, which is formed by 5 sepals being fused together. And this is 3 different angles of a Bossea heterophyllid. So looking at it from the side, you've got the standard, the wings and keel, the coloured, but the green structure behind the petals is the calyx. And if you have a look and sort of look top and bottom of where my cursor is, there's actually often 2 groups of those sepals. So not 5 identical, often 2 above. This forms one group, and they can be quite different to the 3 lower sepals. So that's why these next 2 photos, a view from the top shows 2 sepals that are almost joined together for their length and almost truncate, so squared off at the top, whereas the bottom 3 sepals have got that typical toothed look. Sometimes they're lobed too, they look different. So that's a really good thing to look for when you're looking at a flower. And also there's a structure on a calyx, either on the calyx or the stalk of the flower, which is called the pedicel, is also really important, and that's the bracteole. I'm going to point it out on this one so you can see it as a whole, but I'll be looking at it in more detail. So just at the base on the Bossea, on this Bossea, they're quite low on the pedicel, close to the stem. So they're a pair of bracteoles. And those bracteoles, the size, the shape, the position is very important diagnostic tool. So we've got from the side, the top and the top and bottom views. So hopefully you can see there, and that will vary across genera as well. You're not going to learn everything in one night. If you can take home a couple of things, it'll get you started. And a lot of these things is if you're looking at keys to learn or to identify peas, or even identify a genus. If you're looking at a key, a lot of these structures will be mentioned. So I mentioned the bracteoles, so they could be on the calyx, they could be on the stalk of the flower, the petiole. And by position, so you can see in these 2, One's Pultonea, one's the Templetonia. They're in different positions. They look different colour, different size, different shape. And a Pultonea will 99% of the time will have the calyx, the bracteole positioned on the calyx or just at the very base of where the calyx in this, it's not always, really defined. But whereas you can see on the Templetonia, this is the pair of bracteoles here, a side view, and circled here, they're on the pedicel. So already we know Pultonea has got bracteoles on the calyx and fused stipules. They're the two most important things for a Pultonea. And given that there's 120 species, that's you can cover a lot of species just by knowing those two things. And also, I'm talking about the ones that are present, but also the absence of that bracteole. So not every pea has them, or not every genus has bracteoles. So even it will help you know another genus because it doesn't have a bracteole. And that's, I'll talk about that in a moment to help with Phylota and Aotis that we're going to separate. So yeah, not having them is also an important thing to be able to recognise. We'll just continue with the rest of the flower and then we'll look at Phylota and Aotis. So after bracteoles going lower on the flower towards the bottom of the stalk, you've also got bracts and scales. Now bracts, I've got a photo here is a Victorian species, quite endangered, I think. It's not very common, but it shows these ovate bracts very clearly, these brown bracts around the flowers. And they're similar to, if you know Pultonea retusa from around in New South Wales, it has bracts like that as well, and they're caducous. So it's a bit like deciduous, but it's not seasonally based. It's based on the flower opening. So as the flower opens more, those bracts will fall off. So you can see them while it's in bud, but once the flowers have opened, you won't see them. And that's a really good, in Pultonea, I know in Petra's area, we've got Pultonea retusa and Pultonea lineaphylla growing together. And one has bracts that fall and the other one has persistent bracts. It would have been good if I had had a decent photo of that, but I didn't. So I've got Pultonea rose samarinifolia here, which also grows in the Sydney sandstone. And it has, the bracts are overlapping here. Hopefully you can see it enough. I'll try and outline one. And they're persistent. So even after these flowers die, you'll still probably you should still be able to make out those bracts because they don't fall off like the other ones do. So it's a really good identification, if you've got two similar species growing in the one area, or two of the same genus growing in the same area. So this is actually, whereas that one is ovate, this one's actually got a couple of, it's quite divided in the centre there, and the centre of the bract is covered in silky hairs. So you've got the brown edge and then the white hairs in the middle. So that's one way. It's just another diagnostic feature. And then you might have on another genus, and Platylobium's a good example, it has scales as well as bracts. So at the bottom, starting right down here near the leaves, the bottom of the flower stalk, and you actually can't see this flower stalk, it's concealed by scales and bracts. So the scales are these smaller ones. They've got a hairy margin, but nothing in the centre. And then the larger ones are the bracts. You can see a difference there. Interesting, Platylobium, I mentioned before about how the calyx differs, and they've got the two groups. Platylobium have got two really big lobes. That's one of the lobes of the calyx. So they've got two really large ones. They're quite, you can see they're soft, softly hairy, and the colours. So always worth looking. Don't just look at the front. If you're taking photos for iNaturalist or identification, always get as much detail as you can from behind as well. So look at aotus and phylota, and the clue there is in the names. So aotus translates to without ears. Aotus doesn't have bracteoles. So that's, if you see a calyx and you can't see a bracteole, you've got this deep incurved keel. It's likely aotus. Phylota has got it translates to leafy ears. And I've tried to point out here that what's circled is actually a bracteole. It's not a leaf. Underneath it is a leaf. So they look quite different. It's wider at the base. And it really is, I don't know whether they're that big on all phylota, but there's just an example. But that bracteole, even after the flowers start to fade, you can usually still see that amongst the cluster of flowers, which is also a difference with these is where the flowers are they, how are they grouped together? So an inflorescence is the term we're looking for there. Look at the inflorescence and see, are they, is there one in the axil? Are they grouped together? Are they terminal? Where exactly do those flowers sit on the plant? And in aotus ericoides, they're just single flowers in the axils. So the axil is the angle between the leaf and the stem, and that's where your axillary buds form. So new growth starts in the axil. Whereas in a phylota, they're actually quite, the flowers are quite densely clustered at the end of the branches. They're not terminal, but they are clustered together towards the end. I'll just go back. This is what you'd call, so the Pultonea rosemarinifolia, that's a terminal inflorescence. There's a lot of them, so even the number of flowers in a head may help with identification. So that's a terminal inflorescence at the end of the branch. Okay, let's move on. How am I doing for time? I won't spend a lot of time on the leaves. It's mainly to show you the difference between a simple and a compound leaf, in case you're not familiar with that term. So it all depends on the leaf, the lamina, the leaf blade, in relation to an axillary bud. And that's the axil I mentioned a moment ago, where the petiole meets the stem. So if there's only one leaf blade, it's a simple leaf. But if a leaf has got, you can see more than one, they're leaflets. So you won't get flowers or new leaves coming out from the axils of the leaflets, only at the bottom of the leaf. So that's a compound leaf. And that can be anything from, a pair of leaflets to, up to 50, whatever. Yeah, so I've just got a couple of examples there of compound leaves. And also in between, I've got a unifoliolate leaf, because that's common in pea flowers. And it's actually, it's a compound leaf that's been reduced to one leaflet. So even though it looks simple, that's a single leaflet that was once a compound leaf, but has been reduced over time, evolution, to one leaflet. And it's recognised by an articulation or a jointed petiole. And that's actually, so it's actually got the stem of the leaf and then a join, and then the leaflet has got a little stem there as well. So a petiole and petiole separated by some form of joint there. And there's an example here in this photo. It's actually got a little spur at the back of that joint, and that's Bossia Stevensonii. And in the top right-hand corner of this slide is just to show you that's a trifoliolate leaf. They're common in glycine, Canedias. What's the other one I can't think of? Your Desmodium group. And the thing to look for if you're trying to identify those is look at sometimes that central leaflet has got a longer petiole than the others. So they're not, they're not the same length. And there's often a pair of structures. I've got my, just move that out of the way. There's often a pair of structures here that are stiples. So they're like little mini stipules. And sometimes they'll be on the central leaflet only, and sometimes they'll be on all of them. So just something to look out for if you're trying to, with climbers and things, you'll have those. We'll look at, I think I've got to fly through these, but these are just some examples of stipules, just to show you the diversity, both across genera and also within each genus. So the top three are all Pultonea, but you can see how different they are. Pultonea rosemarinifolia, and these, just because you're difficult, there's no scale on them, they're about 10 millimeters long. Pultonea stipularis, 10 to 12 millimeters. That's the papery structure that's obscuring the stem. And Pultonea flexilis is only 2 to 3 millimeters long. And they'll be joined behind that leaf, behind the leaf stalk. So in the axil, those stipules are joined. That's what says I'm a Pultonea. Bossia Stevensonii, which is one I just showed the little spur. These are the stipules. They look leafy, so you probably wouldn't even know they were there. They just look like more leaves, but they're actually the stipule pressed to the stem at the base of the leaf. And it's a good way to distinguish Bossia Stevensonii from Bossia heterophylla, where they occur together. Bossia heterophylla stipules are very, very small, but these, once you know what you're looking for, are quite conspicuous. And Bossia Stevensonii is usually a lot hairier, the others glaucous. And on potilobiums generally have spiny or bristly stipules. So these little spiny structures, I've just gone too far, didn't know I could do that. These structures here, there'll be a pair at the base of each leaf, and that's the underside of the leaf, just to show you the stipules. That's Potilobium aciculiferum. But have a look at Potilobium alicifolium, is probably quite common, especially in eastern states. Have a look at that next time and see if you can recognize the stipules. So we'll get on to pods. I might run out of time here, but the pods are really, there's so much variation. I mean, when they're not in fruit, if you can, when they're not in flower, if you can find fruits, they'll possibly tell you the genus. And an example here is how they change over time as well. So the three at the bottom here, Platylobium, and so immature pod, a pod that's fully open. So when they open on maturity, that's called dehiscence, and often they'll curl around and stay on the plant for some time. The open pod here, then same plant, and you can see the fleshy aril that I spoke about earlier on the seeds in the Platylobium. Very similar to Bossia pods as well. They're both in the Bossiae tribe. Gomphylobium, it's an immature fruit, and you can see how many ovules are in there that are developing into seeds. and just the number of seeds in a pod can also help you determine a genus. So yeah, and said before, those arils help aid in dispersal because they're ants will take them. They've got a hard seed coat which needs to be broken. That dormancy needs to be broken for if you're propagating and trying to grow them for your area. And they'll often have an explosive seed release. So if you're looking to collect seed, some just, as soon as they'll get hot, they'll explode and the seeds will go. So they're not an easy seed to collect. So a few more pods. Two on the left are both inflated, Gonfalobium and Hovia. Gonfalobium's got a slight compression, so it's a little, so you might be able to see a bit of a difference there. Hovia, they're not mature yet. They will go brown. That's just while they're still developing. Typical Bossia pod, flat, oblong, and with a very thick suture along the edge there. Devesia pods are triangular. So if you find a nice obliquely triangular, I should say, use your imagination there. Yeah, there is. So that's, Devesia have triangular pods, and you can see one little lone seed in there. That's it. Oh, an ovule. So that's just sometimes there's one or two seeds in Devesia pods. A few more. These, the three on the left are all quite similar in size. Dilwinia, they're still immature, but sometimes you'll see this, the remains of the style is persistent in fruit. And this is an Aotis. So they're all in the Mobilia, Mobilia tribe, and we've got another one here, Mobilia as well. It's actually the genus Mobilia, and a distinguishing thing about their fruit is they're longitudinally divided, so you might be able to just see a depression there. So it's actually got like a septum or a division between the fruits. So it's a good way to pick it from some of the others. So if I've got time, I'll quickly run through. This is just a look at a genus, pulling all those things together that I've told you or that we've spoken about, and putting them together. So the Pultonea, about 120 species. And I think I've already said the main things there is the stipules fused behind the petiole and the bracteoles being present on the calyx or at the base of the calyx. The seeds have an aril. So I'll just pick out the important things in these. There's only about 8 genera to go through. This, you can see that's the stipules there. They're quite fine at the base of the leaf and on the side of the bud. Often a bud's easier to pick these parts from than it is on a flower. So you can see the bracteoles, just slightly different colour, a red colour there on the Pultonea spinosa. That's the bracteole. Devesia, all phyllodes. They're often spinescent or cylindrical in shape. The pods are triangular, and sometimes minute stipules or absent, and they don't have bracteoles. So hopefully you're starting to see that by a combination of things that you pull together, you can identify at least the genus level, and then that's a starting point to identify the species. Gastrolobium, it's a major component of the understory in southwest of Western Australia, and there's only 2 that in Central Australia. The rest are in Western Australia. 1 or 2 seeds, and they don't have bracteoles. Another point of difference. Jacksonia, I haven't mentioned Jacksonia in Mobilia tribe. There's most of these in Western Australia. It is another big group, and they're mostly leafless and sometimes spiny. But the thing to notice with them, and have a look at, if you're in the eastern states, have a look at Jacksonia scoparia. They often, the calyx, so that's a group of sepals joined together, they're often reflexed like this, like recurved, turned out. That's one way to recognise them. And also their seeds are quite distinctive. They're often compressed like this and they open at the end. So there's a couple of tips for identifying Jacksonia. Gomphallobium, Gomphallobium. Here's some of the other colours I talked about, a big range of colours, and it's a gorgeous group of peas, about 50 species. 2/3 of them are probably in Western Australia. So even though I haven't got a lot of photos of Western Australia, they do feature heavily. A lot of there's just so much more diversity. The two centres of diversity for peas in Australia are the southwest, so in Western Australia, and the southeastern corner. So New South Wales, Victoria, South Australia. We've got the big numbers of pea flowers. It's the only genus in the Faboideae tribe that has compound leaves. And here's an example here. This is a palmate leaf. It's compound, but it's palmately compound. So you can see that it's like three fingers spreading out from one point, and each of them's got a tiny little stalk. They're the leaflets, and then you've got the main stalk of the leaf. And the number of leaflets is important for Gomphallobium. Gomphallobium glabratum around the Sydney area has 5 to 7 leaflets. So, it can distinguish it, pick it out straight away from the other ones in the area. It also has a persistent calyx. So this calyx, petals have gone, but the calyx stays on the plant for a long time. That's Gomphallobium grandiflorum with the narrow leaves. This pretty orange one is from Nunes in the Gardens of Stone. That's Gomphallobium uncernatum. Dilwinia has got the typical Mickey Mouse ears. It also has leaves have a groove along the upper surface. So all Dilwinia have the grooves, but not just because it's grooved doesn't mean it's a Dilwinia. There are some tricky Poultineas that have the leaves tightly enrolled like this, and they look like they've got a groove on the top as well. So that's just one thing isn't always enough to tell you what a plant is. And their bracteoles are usually small and on the pedicel. The Mabelia, we looked at some fruit before, just another couple of examples. It's another genus that's got a lot of different colours in it. Mabelia speciosa, and in the Sydney area is purple. And here's another example of the fruit with that longitudinal divide down the centre of it. So a couple of different Mabelias there. Eutaxia, the Western Australia, I talked about the foliage being opposite and decussate. We've only got a few in the eastern states, all but 3 are in Western Australia. And as you can see that foliage in the bottom left-hand corner. They don't have stipules. And I left Bossia till last. All the others were in Faboideae tribe. Bossia is in the biggest genus in the Bossiae tribe, along with Platylobium, Goodia are also in the Bossiae tribe. And the way the tribes are, the main point of distinction in the tribes is the way the stamens are fused together, whether they're free or fused. And I try not to look at those because that's, I think I try to show things that you can identify in the field without going to that level. But if you've got no idea whatsoever what genus it fits, the first thing you should look at is have a look at the stamens and see whether they're fused together and how they're fused together. But that's, all I'll say on that. Bossia, very morphologically diverse. half of the 80 species in Western Australia. And as you can see from these two photos, they're just so different, absolutely different. The one on the right is Bossia scolopendria, grows on our Sydney sandstone, and it's got the flattened stem. And there's 25 species that have flattened stem across Australia. Bossia walkeri has like a grey foliage, and it extends from Western Australia right across to Victoria in the western arid areas of New South Wales and Victoria. But there's 25 with this it's called a cladode, and it's actually a flattened stem. You might see leaves when they're young, juveniles, but mature plants have the flattened stems, compared with this one from Western Australia, Bossia dentata. But this is a good example of what I've mentioned before. This, and as you've probably seen from the photos, all the flowers are very different. But this one's got the keel and wings are longer than the standard, and the bright red. They're probably evolved to be pollinated by birds rather than bees. Very distinctive calyx there, and the typical Bossia pod as well. Yeah, fascinating group of plants, the Bossias. So, take-home messages. Where am I going? Happy to hang around if people have got questions. So the take-home, it's a process of elimination. You need to observe. So look closely, use your hand lens, or I find I hardly forget my hand lens these days with a camera in hand and with the zoom on them. They make good magnifying lenses, so and you can take a photo at the same time. But you do need to look closely at some things, flowers, foliage, and fruit, and in combinations. Look, I've got these. This is the same plant from what I'd call the front and the back, if you have a front and a back to a plant. But just looking at the flowers here compared with what you see behind the flowers, you can see the calyx. If you look closely, you'd be able to see the bracteoles. You've got the leaves are more visible in that photo. You can see the flower arrangement. So just looking at those two angles will tell you a lot about that plant. The growth habit, so, is it prostrate, tall shrub, tree, a vine, all those characters. The geographical location and the habitat. Is it, growing in sand? Is it growing in a swampy area? They'll all help you identify, pull together to identify the pea flowers, and know which species are in your region is probably a good start as well. So that's pretty much the end. I did have, we mentioned iNaturalist, don't have to do that again, and the Australian Native Plant Society. If you are a member of APS New South Wales or a similar group, every state has an Australian Plant Society, not all named the same, but if you're members of that, you're welcome to join the study group. There's no fee involved. But my previous newsletters are available online anyway, and a lot of this is covered in it. So if you Google Australian Pea Flower Study Group, I'm sure you'll find them. You just need to dig for the resources and look for the newsletters. And or you could scan that with your phone, and that'll take you to the Pea Flower Study Group page. And I think that's all. Sorry, I've just screwed. I've not a lot of time for questions.
That's okay. Thank you, Shirley. I hope if anybody wants to hang around there are a couple of questions in the chat. So
Okay.
I think one of the sort of two main ones, if there will be a PDF available, and if people could use your photos for IDing in the field, because they're very clear and loved your photos.
Yes, I will. I should be able to do that. Make that available.
I mean, otherwise the video will also be
The
available and
video,
people
yeah, it's
could
probably
take
easier to look at
screenshots of
the
it. So
yeah,
if
yep.
that might,
I can share that with Petra to share with.
yeah.
Yes.
And otherwise there were sort of two more detailed. If the calyx pattern, is that only for the Bossia? It must have been one of your first
They vary.
start
That was just an
slides.
example. The Bossia has the two broad ones at the top and the three finer teeth at the bottom, but yeah, there's variation. I mean, some might be equal, look the same. Yeah, just have to look for each. Once you know a genus, try and have a look and see what they are.
And could you please explain incurved keels?
Oh,
I think that
okay.
was maybe with the Gomphallobium,
Yeah, no,
possibly.
the Aotus and the
Oh, okay.
Phylloda both have. So it's just I suppose it's like someone's taken the keel and push the end in. They're just sort of they makes them very deep, so they stand out if you look at them side on. So if you compare it to some other genera, yeah, they where's I probably haven't. I just I'd have to share it again. They just look deep, and you can see it below the. It sort of protrudes below the wings quite significantly. I actually, that photo that I had of the aotus or the one of them, it actually looks like a pelican's beak. So it looks like the wings, the top, and then the deep curve below. Hope that answers the
Yeah,
question.
I think so, yeah. And I think they're using a magnifying glass. I think you explained at the last slide that you can use but
Yeah,
nowadays a
magnifying.
good camera is really, I find, nearly better than a
Uh,
magnifying glass, quite honestly. So
Yeah, I find the camera,
yeah, the
and I
phone
find
cameras.
when I'm in the field that by using the camera and zooming in, and other
Mm,
people can see, and I can point out, it's
yeah,
almost like it's easier than
yeah,
you looking through and explaining to someone what to look for. So the cameras are great these days
yeah.
if you've got a good camera. If
And I
you
find the magnifying is nearly better on the camera than with a little
yeah,
magnifying lens you used to
two or three
have.
times, you could see a lot, unless you're really looking at the stamens or something. But even then, you could probably get a really good photo,
Mm.
magnify it with your camera. Yep.
Well, I think that's sort of, there are lots of thank yous. I think you can read through those. But yeah, I think that's all for it.
No,
Does anybody else? You can always
okay.
unmute yourself and ask a question if you would like
Oh, I
to.
can't find
Otherwise,
this.
I think lots of thank yous and
Have a
Yeah, I have a question.
yes.
go for it.
So basically, you think looking at these stamens isn't really a
It,
like a practical way to identify, like out in the
It
field?
is. It'll put you into a group. So if you
Yep.
find it's got 10 free stamens, that'll tell you it's in the Faboideae tribe. But then you've
Okay.
still got to go to genus. So let's say if you don't have any idea where to start, I would do that. But I think just for practical reasons, I like to show, how you could maybe look at it in other ways to work
Yep.
it out without delving into there. But you'd certainly need it if you have no idea. And then you sort of start at the very beginning. Okay, it's an Faboideae tribe. What genus have I got? And you can work down. But a lot of genera you can tell just by looking at particular features.
Yep. Cool.
And I
Um,
think Lisa raised her hand. Do you have a question? No, I think it's
Yes,
gone again.
thank you.
Oh, okay.
Hi. Sorry, I haven't got my video going. Shirley, yeah, thank you. Fascinating information, like everybody's saying. I was wondering do you find that some of these species or genera grow in different directions, like according to who's going to pollinate them, or do they all flower kind of in the same direction if you've got two similar species next to each other?
Wow.
I'm down at Central Coast, New South Wales, and yeah, we've got lots of flowers come out at the same time. And I find that sometimes they're all facing towards the ground or they're all facing towards a particular angle, and I wondered if it was to do with a different pollinator that they're aiming for or
I would have
something.
thought it'd be more following the sun, but I don't.
Yeah, me too.
Yeah, I mean, and some of those, I think there's a difference. Some of the, like the Bossy I pointed out with the red flowers, there's quite a lot more in Western Australia, and some of the flowers are actually at the base of the plant,
Yes.
and that could even be pollinated by mammals. I don't think there's any sort of, whether they're studying that, but it's suggested that it's a possibility because they're on the ground, the honey possums and things like that, or might be ground dwelling birds or something.
Okay, so nothing really clear that you know of.
No,
Okay.
I haven't heard of that.
Yeah, thank you.
But something with the pollination that I found interesting when I was doing this is the orchids mimic. They found in Western Australia that orchids, mainly the donkey orchids, are mimicking pea flowers. They've got the same colour reflectance, and their flowering overlaps, so that they're attracting the bees because they look like similar to a pea flower, and they're getting pollinated without a reward to the pollinator. So
that's really interesting.
An interesting study that they're done in Western Australia. Yeah.
Okay, thanks.
And we've got one more question or hand up by Fabaceae. Sorry if I pronounced that wrong.
Thank you. That's me, Fabi. Yes, I'm a bush regenerator in Sydney. And I was wondering, you said that they're nitrogen fixers and they help improve disturbed grounds and with fire. So how do we practically implement that? Can we plant the seeds in disturbed ground so that they can become better for natives, or in relation to a fire as well? So if there's a fire regime that's to be followed and we're weeding an extensively weedy patch to give the natives an upper hand, so can we introduce pea species or seeds to improve?
Probably not. I don't know a lot about the bush regeneration side of it, but I know with I don't know whether when you first started with regarding the nitrogen fixing. I mean, that's if you're introducing the same peas, whatever's in the soil there, what they need is probably the rhizobiums there. What they do have trouble with is growing peas out of the area that they're from because that soil mightn't have the rhizobium. So some are very specific. There might be just one rhizobium species for that pea, whereas others might be a little bit less fussy and any rhizobium species. So some have a one-to-one relationship, whereas some they're not as fussy. So with threatened species in Victoria, they're getting the rhizobium from the soil, growing that in the lab, and then when they grow their plants on, they're inoculating it with that rhizobium because they'll struggle to grow without the rhizobium. So I don't know if that's what you
yes,
were asking, but
it's
probably
more
fire would be the next thing, but I can't really speak on how, I don't know those practices.
Oh, okay, great. Thank you so much.
Okay. Marie's got a question. No, it's not fungi. So orchids have a mycorrhizal association, and that's a specific fungi that they need, but peas have a bacterial association with bacteria, and it's a nitrogen fixing. So rhizobium is the genus for nitrogen fixing bacteria. I've only just discovered that. I've only just found my list here.
Good. I think that's probably it for questions.
In that chat, I think when I've had P study group meetings, we've been able to print that chat out. Would you be able to get that from the Zoom or find out if that's available?
Yep, that will be available. Yeah.
Great. It just tells me, because I haven't had a chance to look at them.
I think you need to download the chat separately sometime.
Oh, can I do that from
Oh,
here?
Yeah, you can definitely, like, I can save the chat for me
Okay. Yeah.
and everybody can, but I think you can save it separately as well. And I'm not sure if it always comes through on the
Okay. I
recording.
don't know how to do that.
I get a copy of the chat to my computer and I'll share it with you, Shirley.
Okay. Thank you.
Thank you. Yes. Thank you, Shirley. I hope everybody is now going to look very closely at stipules and bracteoles and calyx and have a closer look at all the yellow
I
peas
hope
around.
so.
And upload it on iNaturalist if you want some help with IDing them. But yeah, take the right photos, as you could see. It's
Yes.
not take one from the top and miss out on all the good bits of the stipules and the stems and the bracteoles. So
Don't take a photo from a moving car, for
yes. That sort of thing. So, and yes, as you can see on the slide as well, there's the grassland resurrection, like workshop forum was on, and it will all go live on 5th of June. So more things to learn from AABR. So,
okay, cool.
and yeah, any more information about AABR, please contact us. Or if you've got ideas of other talks or walks or anything, please contact us and join AABR if you haven't yet.